Welcome to the Wolseley Sustainable Building Centre, a £3.2 million facility designed to show our customers and prospective customers real practical solutions in terms of sustainable construction. The idea of the building is to try to showcase as many different circumstances as possible. So, whilst this might be one building, we have two very distinctive building styles, a lightweight timber frame structure on one side of the building and heavy mass structural concrete on the other. And this is allowing us to show solutions which are effective in both domestic and non-domestic settings, in new build and refurbishments. The rule for the products to be included in here is they must be available in commercial quantities to commercial timescales. So this is nothing about knitting your own yogurt. This is about genuinely practical solutions which are available today. Now let's go through and look at some of the solutions which are available in terms of heating and hot water. And to do that, we're going to move into the main gallery, if you'd like to come through. As we enter into the main gallery, the first thing I'd like to draw your attention to is the output of our two installations of photovoltaics. And here on the wall you can see the meterage, which is giving an indication not only of what we're getting at the moment. Unfortunately, you've come on a very overcast day, but probably more meaningful is the outcomes of our PV since they were installed. And these two figures here are showing us the cumulative total of the electricity we've generated since the panels were installed on the 23rd of May 2008. Over 5,500 kilowatt hours of electricity. Now generally, domestically, we consume about 3,000 hours per year. So we're getting about 2/3 of our electricity from this particular array, which is certainly a practical proposition in most households in the UK. Bit of an urban myth here. Some people think that solar technologies can't work in the Northern Hemisphere, and well, this proves to you they certainly can. PV has certainly become a very popular install over the last 12 months since the introduction of the feed-in tariff, which began on the 1st of April in 2010, and which now gives you as a householder or you as a building owner a return against every unit of electricity you generate. And that, for most cases, would be for a 25-year period. Now let's have a look at the first heating device, which is our array of air source heat pumps. And here we can see our array of 6 air source heat pumps. Air source heat pumps are, I think, going to be one of the winning technologies going forward. They're providing us with the outcomes of heat and hot water for our homes, but at much greater efficiency than a standard gas boiler, and also much lower carbon emissions. Now you can see the 6 heat pumps here, all of which are very different sizes and shapes, but remarkably, all of them have very similar outputs. Heat pump technology might be new to the UK as a heating device, but we all have an air source heat pump in our house. It's called the fridge. And these devices are working in exactly the same way as a fridge by recovering the very low grade heat in the ambient air and going through a refrigeration process and a heat exchanger to provide hot water either for very efficient convector radiators or for underfloor heating. An air source heat pump is a practical device provided we're putting it into a well-insulated building. The efficiency of an air source heat pump is measured by the coefficient of performance. So a modern gas boiler would be 92% efficient. That's 1 unit of energy in, 0.9 out, whereas an air source heat pump would be gaining a coefficient of performance in the region of 3:1. And that makes it a very efficient heating system indeed. The outside footprint varies by size, and you can see in the array here that there's a huge number of different variations in terms of size and format, and yet all of these heat pumps have a very similar output. The next technology we're going to talk about is a very old technology. We've talked about burning fossil fuels. Well, here's the earliest fossil fuel of all. This is about burning wood. We've got two forms of device here, a rather typical log burning device, and next to it a very modern biomass pellet boiler. The beauty of biomass as a fuel is that it has no carbon emissions, because wood consumes as much carbon on growth as it releases on combustion. And now we have these very practical devices which are allowing us to provide heating and hot water in the modern house. This particular device from Baxi has a top hopper with about 30 hours fuel, and it is fully modulating, allowing us to control the heat output and to generate hot water for our radiators. Next, we're going to have a look at a combined heat and power unit. Now, this looks like a conventional gas boiler, but it's very different because the output is not only hot water, we're also getting electricity. Two heat engines in this device, the Baxi EcoGen. At the bottom we have a Stirling engine, which gives us access to 6 kilowatts of heat and 1 kilowatt of electricity. And then above it, a conventional heat engine, which gives us access to another 18 kilowatts of heat. Now, this is culturally acceptable. It's a wall-hung device. It's similar to most people's gas boilers, and yet it's giving us security of supply of a kilowatt of electricity. Most of us will run our homes on about 800 watts. And also the output in terms of electricity qualifies for the feed-in tariff, and that means that users will receive 10p per unit of electricity generated for the next 10 years. Next, we're going to have a look at solar thermal. So, solar thermal, our biggest selling renewable, hot water from the sun. And we've got two variations on show here at the Sustainable Building Centre. First, a flat plate panel on roof. You can see it projecting from the surface, and this is a large radiator on the roof. Now, the Sustainable Building Centre is providing BPEC accredited training courses for solar thermal insulation, and we have 6 roofs in the Sustainable Building Centre with a variety of different tiles and fittings to allow people to do fully accredited training. Next, we'll have a look at evacuated tube. Now, the difference between flat plate and evacuated tube is fairly obvious in terms of appearance, but also in terms of efficiency. An evacuated tube system will on average be about 10% more efficient than a flat plate, but of course it will also be 10% more expensive. We do a variety of evacuated tube systems, and these particular units are much more easy to install because each unit is screwed into the manifold. In both cases, we're generating domestic hot water. This is not a heating device. It is for generating stored hot water. In general, the best locations are facing due south, but the system will work anywhere between southwest and southeast, and in most circumstances, it will be a 2-panel installation. Plum Centre are also offering an on-roof installation service so that installers can come to the job and work from the tails inside the roof. Next, we're going to have a look at a ground source heat pump. Now, a ground source heat pump works in a very similar way to the air source heat pumps we've already seen, but in this case, the heat source is the ambient temperature of the ground, and we're collecting that heat from a horizontal collector laid outside the building, where we're picking up approximately 5 degrees of heat. It's the same refrigeration process, it's the same heat exchanger, providing low-grade heat through either convector radiators or underfloor heating. Now, a well-sited, well-installed ground source heat pump should offer a coefficient of performance in the region of 4 to 1. And a good ground source heat pump will last about 30 years. That makes the return on investment a significant benefit. Next, we're going to have a look at a high efficient pump. Now, you'll all be familiar with circulatory pumps. We all have one on our central heating system. What you might not be familiar with is variable speed pumps in the domestic sector. A normal circulatory pump is either 100% on or 100% off. In this case, once the inertia has been broken, the speed of this pump modulates back and it'll be running at in between 5 and 8 watts as opposed to 60 watts on a conventional pump. Now, if we were replacing a D-rated pump, we would be saving about 400 kilowatts a year, which would be about £52. You would pay about a £40 premium for this pump, but it's a straight replacement part. The unions are identical. And this is a way we can all make a very significant saving in our homes. Let's not forget water efficiency. Water is going to become an increasingly difficult problem for us all. Here we're able to demonstrate some very water efficient products, including low flush toilets with a 4 and 2.6 litre flush, completely waterless urinals, and very low flow brassware. What about showering? Very emotive subject. We all like a powerful shower. Here we're able to demonstrate a shower head which makes a saving of 75% in terms of water usage. And it's all in the head. The valve is completely standard. So there we are. A massive array of products which are completely practical. And you can see them all in the sustainable building sector. Who knows what's coming in the future? But one thing I can guarantee you is that Wolseley will be in the forefront of producing and developing solutions which are practical and affordable.
Do you need to be inside?
Yeah. Was me. Keep quite low. That's good. Do it while you do it. That's good.
Ja. Nou, right.
That's it. And just measure the other side.
Sit back at that. Have you noticed your ladders have been